Hello, everyone, and welcome to another episode of our weekly Cloud on Air Innovator Series. I'm Chloe Condon, a cloud advocate at Google, and I'll be your hostess with the mostest each week as we dive into different technical topics, watch demos, and learn best practices from some of our top experts here at Google. If you joined us last week, or the week before that, welcome back. And if you're new here, welcome. We're so excited to have you join us and be a part of our community. Now, if you're joining us live, you may notice that we have a live chat. Feel free to use this space to interact with other viewers and ask any questions that you may have about the topics being discussed in today's session. One of our moderators will try to answer you live in chat, or you may just be lucky enough to have your question answered live on the air during our question and answer session with our speaker at the end of this presentation. And if you're not joining us live, join us next time. Make sure to register for one of our upcoming sessions so you can join in on the fun live as it happens. To learn more, check out cloudonair.withgoogle.com, and you'll be able to take a look at our previous streams and register for all our upcoming sessions. You can take a look at previous sessions, or take a peek at some of our upcoming ones where we'll be covering cloud topics like data analytics, Gen AI, security, developer productivity, and so much more. We have a great library of content for you to look through, so feel free to check out our catalog of videos from Google experts that you can watch on demand for free. Without further ado, let's begin today's session. Take it away.
Hello, everyone. Thank you all for joining. My name is Shahzad Salim, and I'm the Data Analytics Solution Lead at Google. I'm also joined by Rodrigo and Nivedita. Rodrigo is a cloud analytics architect under our Center of Excellence Data Analytics team. And Nivedita is a customer engineer with core expertise in data and AI solutions. We are very excited to present to you our point of view on how to accelerate your AI initiatives with Google Data Cloud. For the first 20 minutes or so, I will walk you through our point of view, product capabilities, and reference architecture. And then Rodrigo and Nivedita will walk you through the demos and showcase our newest innovations. We will also have some time to do Q&A at the end. So we have, over many years, right? We have received extensive customer feedback, and the most frequent question which comes up is how to use AI to accelerate business initiatives. Customers are exploring diverse strategies, internal and external. For instance, some customers are aiming to generate new revenue streams by selling their AI models in marketplaces. Others are looking to inject AI in their customer experiences to provide better chatbot experience. Regardless of their specific use cases, everyone is rapidly adopting cloud solutions and wants to use the latest advancements in AI, ML, and data platforms. While the slide covers here business initiatives we are hearing from customers, the underlying technology challenges have three recurring themes. Customers are looking to build always-on experiences. So this requires real-time access to data, both structured and unstructured, for immediate insights and predictions. Customers want to optimize the cloud spend, and they want to prioritize ethical and secure AI for new AI, Gen AI type use cases. So the opportunity is huge, and the developers are in the middle of it. Now to peel a little further, it is hard for an organization to become great at extracting value from data and turning it into a differentiator. In fact, only 19% of the companies surveyed told us that they are maximizing the value of data. The three primary reasons why customers are not able to maximize the value of data is number one, existing data platforms are not scaling. Number two, data sitting in lake houses and warehouses are siloed, and it's very expensive to process that data for the AI models. And number three, data analysis systems are disconnected, which is adding to complexity, costs, and security. So here's a point of view to help solve these challenges. To truly harness the power of AI at scale, you need to bring AI to your data and not the other way around. And By doing this, there are three benefits you will get. Bringing AI to your data eliminates the need to transfer data for analysis. So this streamlines workflows, speeds up your AI development and pipelines. People will continue to work with familiar environments, so that would reduce learning curves and foster AI adoption. And minimizing data movement will in turn lower security risks and data leaks and reduce associated costs. So how do you bring AI to your data? Let's talk about that from three different angles. So number one, creating a single pane of glass for all the data in the organization while keeping the data in place. Number two, executing AI models against the data without thinking about where the data sits. And number three, providing built-in AI in your experiences for developers and analysts for their productivity, as well as for customers for personalization. So when you put all these three angles together, you bring what you once you start putting all these three angles together to bring your AI to your data, you and your teams can truly start accelerating your applied AI projects, because the main challenge of data movement for your structured and unstructured data just doesn't exist. So let's dig into these quickly and how Google can help you with these. So let's talk about the first pillar, which is connecting your data systems. So Google's Data Cloud is the most complete and unified data and AI solution in the market. It supports every data use case and every data user. The core of Google Data Cloud is BigQuery. It is the crown jewel. It is your one-stop solution to break down data silos and streamline unification of your data across the entire data lifecycle. So what does it do? It handles everything from data analytics to AI ML predictions, and it supports all types of data workloads within your organization. It eliminates data movement hassles by integrating seamlessly across your data warehouses and data lake systems. It makes your data usable and accessible across the organization, leading a single security and governance layer for the source of truth. So with BigQuery, you focus on extracting value from your data, not just managing the infrastructure. It's completely serverless and scales all the way up for your very, very large workloads, and all the way, and it scales down to save you cost if you're not using the system. So from your AI initiatives, now you do not have to worry about where your data sits. It could be in your data warehouses or data lake. The BigQuery platform gives you the inherent flexibility to use any data and apply any AI model on that data while providing integration and governance across your data systems, right? And the data doesn't only needs to be sitting in Google Cloud, it could also sit in other clouds as well. So here is a few snapshots of BigQuery. Rodrigo will go a lot more in details when he walks you through the demo. But some of the key highlights of BigQuery Studio is it's a single workspace for all workloads. It can connect to data sitting anywhere in the cloud, within Google Cloud or across clouds. So regardless if the data sits in BigQuery or cloud storage or AWS or Azure, you can connect to it using BigQuery Studio. And then you can apply your SQL, Spark, Python code directly on that data without moving that data. It has integrated assistive AI for code generation and discovery. It provides a single platform access for your developers, analysts, and data scientists. And as I said, it's completely serverless. So it scales up and down to provide you cost optimized environments based on your data consumption. So here's a small example of how BigQuery is helping a customer. This is an example of a used car dealer customer who is using image detection to determine the make, model, and different attributes of the car and providing instant online pricing. Here are the here is the three-step process they are following. So first, this customer is using BigQuery and using SQL syntax and passing the images to our Vision AI and getting the output in a tabular format. Then They use BigQuery built-in DLP capability to identify PII information, right? Like license plate number, and call the blur function in Vision AI to remove any PII information from the image. Then they combine the make and model of the car from the image with their inventory data, and they come up with the pricing. They are using BigQuery for the entire end-to-end use case. So but now we're going to move on to the next pillar. So we talked about integrating all your data assets in a single pane of glass. Now let's dig into how you can apply the AI models, including Gen AI models, to the data. So now this is a different view of the high-level architecture we saw earlier. You could see BigQuery is the central nervous system. It has native integration with Google's foundation AI models and bi-directional integration with our ML system, which is Vertex AI. The key thing here in BigQuery, I want to bring your attention in this section, is BigQuery ML, which is on your left, which is the fastest way to apply our latest AI foundation models and your custom trained models to your data. So once you have connected all the systems through BigQuery Studio as a single pane of glass, let's have a look at how you can apply BigQuery ML to that data. So without needing to move your data out of BigQuery or from any of the other systems, with BigQuery ML, you can train and deploy machine learning models directly using SQL. That means you've got data storage, data analytics, and machine learning all within BigQuery. BQML also lets you access LLMs and cloud AI APIs to perform artificial intelligence tasks like text generation or machine translation. So with BigQuery ML, you do not need knowledge of ML frameworks and programming expertise. It helps democratize ML to the larger organization. To run any model in BigQuery ML, it typically takes two steps. You train your model with the create function in SQL. Then you use a function called ML predict to predict the responses. With BigQuery ML, you can run both AI and ML models. You could see traditional machine learning models on the left side, and you can see the artificial intelligence model you can run on the right side within BigQuery ML. I want to highlight for this section and for the interest of time, the right side where you can see the type of models you can bring to your data. Let's dig a bit more into the type of LLMs you can leverage right within BigQuery. So here are the use cases that let you perform AI tasks in BigQuery ML by using LLMs and cloud AI APIs. So supported use cases includes the following. So you have LLMs, you have natural language processing, and you have machine translation. For LLMs, BigQuery ML has the capability to do content generation, summarization on large data sets. For natural language, it can do sentiment analysis, entity analysis, etc. And on translation side, it can convert an unfamiliar language to English. So what you can see on the right is the second step command for the respective models. In the earlier example, we saw ml.predict, right? But if you want to use LLM, all you'll have to do is replace the ml.predict with ml.generate_text, for example. So in addition to LLM, NLP, and translation, BigQuery ML also has the ability to do audio transcription, document processing, and computer vision. Rodrigo will go in detail in a lot more detail, but here's the example of a use case where a customer wants to extract the keywords from the IMDb reviews. You could do that in two steps, as we discussed in BigQuery ML. In step one, you create a model, right? And in step two, you use generate_text in LLM. If you notice closely, in step two, you have the ability to provide prompt when you are generating text. And at the bottom of the screen, you see the results coming out from step two, which is in step three. You could see the text extracted in column one and column two. You could see if the review itself was toxic, right? So that's your toxicity checker built right within the generated response from the ML model. And then under the prompt column, you could see the prompt provided along with the review. So while using LLMs, right, bringing them very close to your data and being able to provide it as part of your prompts within your MML, within your LLM functions, right, is powerful. Support of vectors take LLMs to the next level. So BigQuery now supports vector embedding and indexes. Vector databases have been very popular for the past few years. However, having a separate database for vector results adds extra data movement and solution complexity. So customers have asked a fully managed service for storing, indexing, exploring, training, and searching vectors across datasets of structured and unstructured data that leverages the power of embeddings from ML models. And that's exactly what now BigQuery also supports that. So Rodrigo will speak about it in the demo, but as a quick example of vector embedding and indexes is this. Imagine you run a support organization and you get thousands of tickets a day. To make your staff more productive, with BigQuery ML, you can summarize the support ticket using LLM ML .generate underscore text. And in addition to that, you can use vector embeddings from all the other support tickets and augment your LLM summary to find closely related tickets and their resolution and provide it to the agent. This can increase productivity and enrich the agent experience and ultimately the customer experience. There is a very nice blog post on Google Cloud Blog. I encourage you to check that one out. So we talked about integrating all your data assets in a single pane of glass using BigQuery Studio. We talked about bringing AI models to your data using BigQuery ML. Now let's talk about how BigQuery uses the power of Gemini to support your customer experiences. In developers experience, we are leveraging the power of AI and GenAI directly in BigQuery with Gemini. We have integrated Gemini right into the BigQuery SQL editor, and we will also have it in our new Python notebook editor very shortly. The traditional way of starting a query is to search for a table or view that you want to start with adding columns, joins, filters, and aggregations. Gemini can help getting started with a new query by typing in your query in natural language and having Gemini generate the SQL. Gemini not only understands the SQL semantics, it also understands the metadata of all the data that is available to you. In addition to SQL generation from natural language, Gemini provides advanced statement completion and summarization of queries. Last thing I also want to mention is that with Gemini, your data and the prompts are securely contained in your own environment and never leaves your environment. In business analyst experience, a business analyst who, in addition to using BigQuery, might also be using a BI tool like Looker. So we have also embedded Gemini into Looker, which is our BI layer. With built-in Gemini, it's like having an always-on assistant. I can help you. It can help you identify the type of data you're looking for in the organization, of course based on your permissions, right? And you can also help it can also help you create the best narrative from your data, again based on your permissions. So within BigQuery Studio, once you have defined the permissions, the permissions are applied to all types of data for that business function. So finance folks can probably look at a lot more data, right, around payroll than a business analyst can, right? A business analyst can look at a lot more sales data. So the type of permissions you come up with within BigQuery Studios automatically get inherited within Looker, as well as BigQuery Studio is your centralized governance mechanism for both data modeling as well as your data security. So you could see on the right that, a classic, a great example is on the right where you can see that how Looker can auto summarize the KPI of businesses using the data. Right, so we talked about integrating all your data assets in a single pane of glass, bringing AI models to your data using BigQuery ML, and helping Gemini create powerful experiences. Now, let me pass it over to Rodrigo, who will walk you through the demo of these capabilities. Rodrigo, take it away.
Thank you for that. All right, so I'm going to highlight features, right, that accelerate the AI journey. And feel free to ask questions in the chat, right? That was the idea. And all the code that I'm going to show is on GitHub. And this is based on the golden demo from Adam Paternoster there on your screen. And so you can take time later to dive in and even deploy the end-to-end solution to your environment. Now, when I think about accelerate AI development, I think of this in two ways. One is in code generation, right, using Duet AI. And then the second one is bringing AI to the data. I'm going to show both angles here in this demo. Now, for this demo here, we're going to use a fictional company called RideShare Plus. And the idea is that this company helps rideshare drivers maximize their profits, and they receive both structured and unstructured data from multiple sources, and also in batch and streaming, right? This is the backdrop. So imagine problems like, okay, how do we help these drivers find the areas that they should go to get the most profitable rides? And we'll start, like I said, with the idea of connecting to your data, right? Aligning with the themes that Shazzy was explaining. So a quick primer here on BigQuery, right? This is Google Cloud, that's the console. If I click here on BigQuery, I will see this integrated environment. And if I expand my project here, I will see a series of data sets, right? So if I go to, for example, my lakehouse, the raw layer, I will be able to see many tables. I can have standard tables in BigQuery, so the data is stored inside of BigQuery in columnar format. But I also have big lake tables, right? So these are tables that are pointing to cloud storage. And then I can have multiple formats. I have 4 examples here: Parquet, JSON, Avro, and CSV. And I will query these tables just like a regular table, right? If I look at the details, I can see it's a big lake table. And you can see here the reference to a cloud storage place. And if I query it, right, I will see results just like any table, right? So I have a single entry point for data that can be inside of BigQuery, that can be on cloud storage. And I can also reach data that is stored on other clouds, right, using Omni. So I have an example here where I have tables, also big lake tables, that are pointing to Parquet files that are living in S3, right? And this query here will unite data from AWS, from Azure, and from GCP. I noticed that one of the questions was the differentiator. So here's one example, right? I have Azure data, GCP, and AWS in one query. So if I run this query here, I have, oh, hang on, because I had it highlighted. If I run this query, I'm going to do some of the processing on the remote cloud, right? So for example, if you notice here on Azure, I have a group by clause. So the group by and the filter will be executed remotely on the remote cloud. So I have BigQuery running on that cloud, and I'm joining everything together in here, right, for the output. I have tens of millions of rows in each of these clouds, and I will actually quickly address also one of the questions. BigQuery, of course, it's excellent for big data, but it works very well as well. If you have a million or less rows, that's fine. The idea is to use it for analytics workloads. If I do a quick check here of the execution graph, I will see that some of the data sources, look at the data location, US, this is coming from GCP. And if I scroll here a little, let me close this out and drag this over. This one here is coming from AWS, right? And one thing that is interesting to notice is that you see there's 7.7 million records. We start with that. But then there's the aggregation, right? The group by, and then only 1.58 million records are sent across the wire. And as you can see here, this took 19 seconds, right? Again, for tens of millions of rows, a query that spans 3 clouds, not bad, right? And what's really interesting here is that it's completely transparent, right? For the developer, this is like a reference, like any other reference. It's just another big lake table. Okay, so my key points for connecting your data is that you can access all of your data with big lake tables, right? You can join data from BigQuery, from cloud storage, from other clouds using Omni, and you have advanced performance features, right? So if the data is partitioned, I will take advantage of partitions, even if it is in cloud storage, right? Hive partitioning. So I have partition elimination, and I also have block elimination inside of the file, right? If it's a Parquet file, for example, I don't have to scan the entire file. I also have metadata caching, so even if you have millions of files in there, you don't have to consolidate those files. We're going to use BigQuery to manage that big data. All right, the next theme that I have is, let me just go forward here, is Duet AI, right? So in the idea of accelerating development, this is fully integrated in BigQuery Studio. So this is BigQuery Studio. I have a chat experience here. I can open Duet AI and I have a chat with Duet AI. So for example, let's say I'm thinking about organizing my data in my rideshare company as a data fabric, right? So what are the list of domains? Can you give me a list of domains for a rideshare company? Here we go. It gives me a list of domains. And with a brief explanation, I can also say, okay, can you give me a CLI script to create those domains in Dataplex, right? So Dataplex is this central metadata repository in Google Cloud, and you can use CLI to run this command in Cloud Shell to create those domains, right? So of course, this is code gen. You have to look at it, right? You are the human in the loop. You will add reliability to and trust to this code, but usually that helps you speed up development significantly. And of course, you can also ask Duet AI to give you a sample query, right? So for example, give me a query that lists the top 10 longest taxi rides and in the morning hours. So I have here from the public data set, the New York taxi rides, right? It picked up the community area, Manhattan, and also the mornings, right? What morning hours mean. So you have a bit of nuance here, and you also have the potential for business terms to be translated to actual field names, right? Because Duet AI will use metadata to inform some of its results, right? So this is really interesting, right? Where this is headed, fascinating. Now, of course, this is based on a public data set, right? It's a good example. It could help you, but what if I want something that is in my context, right? So you can also interact with Duet AI. You see, I have autocomplete, auto generation, and explanation. I can highlight a query and ask for an explanation of it. And I can also write comments here that will queue Duet AI with the project, the data set that I'm using, and then it has the prompt, right? So for example, this one is a very simple one. Find the trip with the longest trip distance. And here it is, right? Select max, and then it used the project name, the dataset name, and the table name that I have specified. The second one here is a little more complex. Write a query that shows the pickup locations with the highest average fare, right? So let me just format this query. So you see you have the pickup location ID, you have the group by, right? Group by the first column. I have maybe some transformations here that could help with performance, maybe not necessary. But again, the code gen here is a starting point, right? And it's something that could help you accelerate your development. All right, so this is the Duet AI. The other thing that I want to show is the notebook experience. So I'm writing SQL in here, and now I can, for example, create a Python notebook, and then I can interact again with all the data sets that I showed, all the tables, all those big lake tables. I can write queries using the BigQuery magic. So this is an example. I'm using a public data set. Or I can, and then what I'm saying here is that run this. Let me see if I can connect with a runtime, and I can run this, and then I will drop this on a pandas data frame, right? So with this simple piece of code, now I have a data frame that will show me the results. Now, pandas data frames are awesome. A lot of people are familiar with manipulating data with pandas. The issue is that if you're working with larger amounts of data, well, you have to load the data in memory, and you know where that goes, right? That's not good. Now, we have big frames that has a very similar API compared to pandas. So if you know pandas, you feel at home. And the difference is that the processing is pushed to BigQuery. So you don't have to load the entire data set in memory in order to manipulate the data, right? I'm actually want to show you a different, because this is taking a little bit to connect. So I will show you a better example for the notebook experience. Okay, so let's switch gears here. But before we go in there, let me just summarize what we have seen so far, right? With Duet AI, you have that integrated in BigQuery Studio, and you can generate code in SQL, in Python. So on the notebook, you can also prompt Duet AI to generate Python code, and you have this integrated notebook experience, right? So now I want to show you a more elaborate notebook, right? More real world kind of notebook. And this is in the theme that Shazzy was describing as activating data with BQML, right? So activating data, with LLMs. Let me show you that first, and then we'll move on to BQML. So let's say that in our scenario here, let me switch to the notebook. Okay, so let's say that it's this Rideshare Plus company. Let's say that they have an app, and let's say that drivers, they do their ride, and then the customers, they can leave reviews about the car, about the driver, right, about their experience. And the way that they leave reviews is on audio, right? And let's say that those audio files, they land in GCS, in Google Cloud Storage, and now it's your job to try to make sense of that data, right? So that's the scenario. What would you do? So I have here a notebook and connected to a runtime, and I'm going to just gloss over these details, and I'll go straight to some of the interesting features in here. The first one that I want to show you is that you can access unstructured data on cloud storage directly from here, from the notebook, even using the BigQuery magic, right? Of course, you can use the traditional Python methods, but in this case, I'm just selecting from a big lake table that has this rideshare audios, right? Let me scroll down and show you how this looks like, right? So if I go here to rideshare audio, this is a big lake table, right? If I go to details, it will show me where it's coming from in cloud storage. And let me switch tabs again. This is how the cloud storage looks like. It's a bunch of MP3 files with recording, right? Recordings. Now, the beauty of a big lake table like this is that I can expose metadata to the developer without granting explicit permissions to the cloud storage bucket. So I can see the metadata, right? Let me show you an example. Oops, I clicked in the wrong one. So back to my notebook here. So let me run this cell, right? And let me show you how I select from the metadata table, the object table, right, looks like. See, I have each of the files in here, all the metadata. And what I did in this code is I added something called assigned URL, right? So remember, I said that the developer does not have direct access to the Cloud Bucket, but if the developer is able to generate a signed URL, a unique signed URL for each file, this would give access to the file itself one by one so that you can apply AI to that file, right? So in my case, what I'm doing later on, I'm going to focus on one trip ID, right? I'll pick just one so that the demo here is a little bit faster. And I'm using the signed URL to pick up that that file, right? And I wanted it to show up here on my notebook, right? Just to show you how I have access to it. You see, now I can play the audio.
I was really happy with the rideshare service I used last weekend. The driver was on time and friendly, and the car was clean and comfortable.
Okay, so this is just to show the direct access that I have. Again, a notebook inside of BigQuery, unstructured data. Now, I'm doing two things in this cell here. One is I want to transform this audio into text, right? So for that, I'm using an external UDF. Let me collapse this here so we can see it. You see, I'm using a user-defined function to call the Google API. I'm sending the audio, and then I'm getting text back, and I'm saving that in a table, right, called customer review transcripts. That's kind of like step one for me. Step two, in step two, I am using large language models. I'm using generate text, right? Again, it's BQML, makes all the power of large language models directly available here in BigQuery, in BigQuery Studio. So I'm prompting the data for each of the transcripts that I generate. I am combining, you see the concat here? I'm combining a prompt with the actual customer review. So I'm doing a first pass, fixing grammar and punctuation, right, in the phrase, and then I'm saving it back to the table. Okay, so just to see, I mean, the possibilities are endless, right? Now you can have a data pipeline where you have a prompt transforming your data, right? I'm going to skip sentiment, although that's also an amazing capability, because I want to focus on theme extraction, right? This is where large language models shine. I'm using Bison 2 here that was released in December. And what I'm doing, let's say that in my scenario, I want to take the customer reviews and I want to classify into very specific categories, right? I want to see this rideshare, and I want to tag those I want to tag the customer review with things like the trunk space is too small, or driving too slow, dirty car, and so on and so forth. So I'm zooming in on features that could help my rideshare drivers provide a better experience for their customers, right? And in my prompt, I'm telling the large language model, hey, give me this response in the JSON format, and here's an example, right? Here's a sample JSON response. Again, I'm concatenating. Okay, this is a simple trick. You can have your prompt, and then the actual text, you see, will become a field in a table. So I can bulk process all my table and get an output like this. Let me show you here, right? This is all live, right? So it queried the large language model. This is the actual text that came from the table. I recently took a ride share, blah, blah, blah. The driver was on time. Here's a key one. Offered to turn on the radio for me. Now in the output, you see the output here, it's a JSON array, drivers like music, which is one of the categories that I asked, right? Let me see, blah, blah. The car was also clean and comfortable. So I have here clean car, right? So I can classify in ways that in ways that it would be hard, would be a lot harder to do this with LDA, for example, right? And I can have that as part of my pipeline, right? It's a built-in kind of thing. There's more to this notebook, right? Customer theme extraction, summarization. Like I said, the possibilities are endless. You can have a multitude of prompts transforming your data, and directly here in BigQuery, right? So I showed you three things. Basically, the three things that I want you to remember: that object tables, they simplify access to unstructured data because they expose metadata, and then you don't need to grant direct access to those buckets to your developers. You have access to a large number of AI services from BigQuery. I showed you transcription, but you have translation, image detect, object detection, and so on. And you can enrich your data using large language models within BigQuery, right? You can write a text. Bison 2 is specifically, that's what I demonstrated here. Now, I'm running out of time, so I'm going to just very quickly show a more traditional BQML, a more traditional machine learning training and inference on BigQuery. And the idea here is that you have, let me just jump straight to the training, right? So training data with BQML is as simple as this. You see, I do a create or replace model, and then I specify the model name, and this is a linear regression. What I'm going to do here is I'm going to imagine that I want to help the drivers find profitable rides, right? And let's say that I have data from past taxi rides with the amount of money that was made. Let's say that I have weather data, and let's say that I have images, right? Let's say that both the passengers and the drivers, they can take photos, and they have an incentive to upload those photos. Now I can process that unstructured data, do object detection, and then see, are there a lot of people in there? Are there people carrying luggages, which means these are travelers? Maybe they're going to the airport. Maybe that's a signal for a profitable ride, right? So I want to train a model with these multiple sources, right? So the first step that I have here is I'm creating a table consolidating all those sources of training data. I have the historical trip data in here. I have weather data that comes from the Analytics Hub. This is a public data source, right? So I have rain data, and I have snow data in here, right? So whether or not it's raining, whether or not it returns a true or false. And I have here the output of a pipeline that I'm not showing here, but I have a separate pipeline that takes those images using object tables, runs object detection, and then I'm just filtering by the tags, right? So I have the number of people traveling, and then I look for tags like suitcase, baggage, rolling, right? And I also have a count of people, right? By looking for tags, pedestrian, person, and so on, right? So this is a create table as select. I'm not going to run this again. It takes a few seconds, not a big deal. But then here, I'm going to train the model, right? Again, this is all SQL. This is all within BigQuery, all integrated. This is BQML. Now, once this model is ready, and I'm going to find this model right here. Let me show you here. See, under the Rideshare Lakehouse curated data set, I have a container called models. I'm just retraining that model with the data that I have. There we go. It's done, right? And if I click here, go to model, it will give me basic evaluation numbers here for that regression model. Okay, so back to my SQL script. This is how I would do an inference. Okay, of course I could do an inference over an entire table. I'm going to show that in a minute. In this case, I'm sending one vector, right? All the features, I'm saying, hey, for this location and this day, right? And for short ride distances, let's say it's not raining, it's not snowing. Is that a profitable ride, right? And now instead of just using predict, I used explain predict, right? So now I have an explanation here. So yes, this number is high and it's positive. So that means in those conditions, it's likely that I'll get a high value ride. And these are the features that participated in the decision, right? The pickup day had a high weight, right? And the people count also had a high weight. And then these three features here, they pulled towards a no, right? But yes still won, right? So I can do an inference, I can have explainability, and this is what Shazi was referring to. Like you bring AI to your data, not all the way around. Now I can update my data, I can update my table with the results of a bulk inference over that ML.predict, right? So I'm saying, hey, take this model, take this data set, and then take the output and update the original table, right? So this is a lot faster than exporting the data and then running the inference and then importing the data, then merging it again, right? It's a huge shortcut. And these models are kept in Vertex AI. So we have all sorts of manageability features there. All right, so to summarize, activating data with BQML, we did in-place inference and training. I showed you that you can easily get explanation of the features. This is incredibly helpful if you're looking for ethics compliance, if you're looking for regulatory compliance, or even to know, is this, are these answers making sense? Am I leaking the output somehow, right? So you can check the model quality with that. And you can easily combine data from structured and unstructured sources, right? So this is it. With that, this is what I had to show. With that, I'm going to hand over to Nivedita.
Yep. Thanks, Rodrigo. So to conclude, we saw in the demo how BigQuery Studio provides a robust, secure, and a collaborative data platform along with Big Lake tables. This foundation is essential for driving better decision making across your organization. In order to activate your data, you have a versatile toolkit to work with, where it is a BigQuery ML or leveraging LLMs in BigQuery or Gemini in BigQuery. LLM, BigQuery ML, and its integration with Vertex AI offers options for natural language queries, custom machine learning models, and trained AI workflows. This flexibility truly democratizes the data, ensures that insights are accessible to teammates with diverse technical background, whether somebody is like fluent with SQL versus like Python. Everybody on your team can leverage BigQuery and like build machine learning models with the technologies available there. Last but not the least, integrating Gemini with Looker and BigQuery streamlines the creation of intelligent business intelligence solutions. This assists you to easily monitor key performance indicators like customer engagement, customer conversion, or the overall growth of your business. With that, I'll hand it over back to Sashi.
Thank you, Nivedita. This was and thank you, Nivedita, and thank you, Rodrigo. That was a really great insight into how BigQuery works. So, how do you get started? So you've learned a lot about BigQuery. How do you bring your ML and AI to your data with either BigQuery ML or LLMs, right? And so how do you get started? So we have a very structured way on how we typically work with customers, right? This is the sort of like a path to production, concept to production, the process we typically end up using. The first thing is we engage with the customers. We explain them, the broader vision of Google Cloud. We do a readiness assessment, right? And then the next thing is we get into like the technical references and the architecture of the use cases you're considering. Then we have SKU of partners as well as our professional services who can help you take the concept to production, right? And then we have a bunch of incentives which align with all these different offers. So this is a very prescriptive way on how we typically work with customers as we go through the journey of maturing their data and AI platforms. So feel free, as part of the follow up to this session, you will get an email as a follow-up, and there's going to be a contact us contact us button. If you're interested in leveraging any of the offers, please fill that form up. We'll get back in touch with you, and we can get this process started for you in as little as 2 days. So or you could or we could go in and or you could read the Google blogs available as well, which is also pretty cool. There's a lot of insight there as well. So with that, my email is shazzy@google.com, SHAZZY@google.com. If any of you have any questions, and if you need any urgent assistance, please feel free to reach out or fill up that contact form, which is going to be sent to you. So with that, thank you for your time. We're gonna go through the Q&A now, and if there are any open questions, we can answer those now.
All right, so let's dive right in. I see a question here from Jairo. On the notebook, do I need to create an instance to use the notebook? No, you have templates of your runtime, right? And then when you hit connect, you get the choice. You can have multiple runtimes or multiple templates if you like, and then you're going to connect to one of those. You do need to define a template. You have a default template that is there for you. But for example, in my case, I have security restrictions, so I had to create a runtime that would have a secure boot, for example, so that I would comply with my organization policies. All right, then we have a question from Luis. Can BigFrames be used to process data queried from a table in Alloy DB, or do we need to copy from Alloy to BigQuery first? Okay, so BigFrames will give you access to tables that are in BigQuery, right? And when I say in BigQuery, Big Lake tables, right? And your options on Big Lake would be, you could have an internal table or a standard table, or you could have a table on Google Cloud Storage, for example, right? That's what you have access to. If you need to reach out to Alloy, if you are in a notebook context, you're probably better off just reaching out directly. That would be one option. Another option would be a federated query, but a federated query would work with Cloud SQL, right? With Postgres Cloud SQL. So it would be that would be another route. A third route would be what you're describing, right? To maybe copy that or replicate that data over to BigQuery.
I can answer the last one. So does it support Bengali language? I just checked the site, and it does. Nivedita, can you paste the link of the languages supported in the chat?
Yes, I just replied to the question with the link, and the Bengali is one of the languages that is supported among many other languages.
Excellent. I think there are three more questions, which I think will be helpful for people, which we typically get from when we are doing the session. So the first is, where can I find the source repository of the code shown? Nivedita can paste it in the Google chat or in the live Q&A. The link for that is available. The demo which Rodrigo was showing, it's all available on GitHub on the Google Cloud Platform, and we could show that one, and we can share that one. The other is, can I run a Spark job from BigQuery Studio? The answer is yes. You can run the Spark on-demand jobs or send a job to Spark cluster in Dataproc through BigQuery Studio. Is it possible to get credits to try something, what we were presented today? Yes, reach out to your account team. Again, if you don't know who your account team is, fill up the contact form, which is going to be sent to you at the end of it, and the account team will get in touch with you. If you're in the middle of evaluation and you need support right away, you can send an email to me at shazzy@google.com, which is HAZZY@google.com. Oh, we have one more question. is it feasible to utilize this AI/ML code for creating a refurbished medical device marketplace within a WooCommerce WordPress web development framework? That's a very interesting use case, and yes, I don't, there are no restrictions against it. And you can also check out the code, which is also available on GitHub, and you can leverage some of the code which already exists. Rodrigo, Nivedita, do you want to add anything to that?
Yeah, I mean, we'll have to look at the details, but like I said, the terms of sharing the code are the traditional ones on GitHub. It's publicly available, but then of course you're encouraged to check, test, and retest as you incorporate that with your application. Yeah, okay, that's a good question. We also have does BigQuery ML use Gemini Pro Vision to understand the video uploaded to Google Cloud Storage, right? Right now, you would need, so here's the thing, with the BQML that I showed, everything that you use in BQML, there's a connection, right, to a model. And the model that I was showing is Bison 2, which is good for text tasks, right? Like the examples that I used. For video and Gemini, we don't have that right now as BQML. That you can use on a SQL, like on a SQL statement. So the workaround would be to use a user-defined function that would call that API, right? And then the possibilities are endless, right? Just like this is what I used to transcribe the audio. It would be a very similar thing, right? I call the transcription API. So in your case, you would call the Gemini Pro Vision using a user-defined function. I think that would be the way to go.
Excellent. I think we answered all the questions. Thank you everybody for joining us for the last hour. I hope you found the session helpful and valuable. Again, if you need to reach out, please feel free to reach out at shazzy@google.com. And thank you for your time. The recording is going to be available, so you could rewatch it if you have any open questions. And if you haven't answered again, please reach out. Thank you again for your time, and thanks for spending your Valentine's Day with us. Thanks. Take care.
Bye.
At Google Cloud Next, we're announcing an amazing show.
All right, cue the music.
We're building the new way to cloud.
So that just means we get to think even bigger.
And now helping you connect like never before.
Let's start with development.
I'm loving this. Super cool.
AI is going to change the game for all of us.
Live on the demo stage.
I can't tell you how excited I am to continue blowing people's minds.
We're now in the midst of one of the most profound technology shifts in history. There's so much more for all of us to explore together that'll power this next chapter of digital transformation.